Good morning, good afternoon, or good evening, everybody. It is wonderful to have you back again. This is Mr. P. Today we'll be doing our guided notes for section 13.8, Geometric Series and Sequences for the honor section of Secondary Math 2. Now, geometric sequence is a term in which the ratio of any term to the previous term is constant, and that common ratio is the constant ratio in a geometric sequence. That is, for example, 1, 2, 4, 8, 16 has a common ratio of 2 because each one of these is double. That is, each term divided by 2 gives us the previous term, or if you prefer, each term times 2, the common ratio, gives us the next one. So the nth term of a geometric sequence, so the first term a sub 1 and a common ratio r, is given by a sub n equals a sub 1 times r to the n minus 1. So in our example above, a sub n would be equal to the first term, 1, times the common ratio 2 to the power of n minus 1, which, by the way, you can simplify as 2 to the n minus 1. So, for example, the nth term of a geometric sequence is the first term of 2 and a common ratio of 3, that is 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and so on, would be a sub n equals the first term, 2, times the common ratio to the power of n minus 1. Why they put parentheses around that is because if that's a negative, that matters, because sometimes they have a negative there. But if it's positive, you can leave it out or put the parentheses in. It won't hurt my feelings either way. Now, it turns out you can calculate the sum of a finite geometric series. The sum of the first n terms of a geometric series with a common ratio that's not 1 is a sub 1 equals 1 minus r to the n over 1 minus r. That's going to be a big deal. See you in a moment. Determine if this sequence is geometric. So to determine if it's geometric, what I do is I take the last term I can see and divide it by the term that came before it. So 324 divided by 108 is 3. So 108 times 3 would give me 324. Now, does that continue to work? Is 108 divided by 36 also 3? It is. Is 36 divided by 12 3? It is. Is 12 divided by 4 3? Yes, it is. So this is geometric, and the r equals 3. The common ratio is 3. That says Leometric, which sounds like a really cool name for a band if that band existed in 1975. Okay, that was odd. All right, so 75 to 40. Well, honestly, I'm looking at this. That goes down 5, down 5, down 5, down 5. So this is an arithmetic sequence, and an arithmetic sequence cannot be both arithmetic and geometric. I guess technically it can if the common ratio is 1. Like, that's the ridiculous series 3, 3, 3, 3, 3, and so on. But just to be sure, if you do 25 divided by 30, that's a 0.83 repeating. And if you do 30 divided by 35, you are definitely not going to get that same amount. 30 divided by 35, yeah, that's 0.85714. Whole bunch of nonsense. So, not geometric. No common ratio exists. Writing a rule for the sequence. So remember, the rule is a sub n equals a sub 1 times r to the n minus 1. So a sub n equals a sub 1 times r to the n minus 1. So if these are geometric, 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is 162, I sure hope. 54 times 3, yep. Which means that my first term, a sub 1, is 6, and the common ratio here is 3, which means that a sub n equals the first term times the common ratio, 3, since it's positive, I'm not going to put parentheses around it, to the power of n minus 1. There. Now where this becomes different is in this case, because 3 times what is negative 6? Well, it's times negative 2. Then negative 6 times negative 2 is positive 12, and positive 12 times negative 2 is negative 24. So this is where it really matters. So a sub 1 is 3, and your common ratio is now negative 2, which means that a sub n is equal to your first term, 3, times negative 2 to the power, that's our common ratio, to the power of n minus 1. And why it's important to keep that in there is because if n is an even number, that needs to be a negative to raise to the power of an even number, which would make it positive, because would make the terms alternate. Okay? There's not much more you can do with that, unless you really, really, really want to take that negative 1 and raise it to the n minus 1 by itself, but that's obnoxious. Finding the sum of a geometric series. Let's go ahead and look up that formula again. A sub 1 times 1 minus r to the n over 1 minus r. So that's not how I write anything. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Did I get that right? Yes. So in this case, the first term is 3, because of the way that these are written. The r is 3 halves. So that's going to be s sub 10, that is the sum of the first 10 terms, is equal to the first term, 3, times 1 minus the common ratio, 3 halves, to the power of n, which is 10, all over 1 minus 3 halves. And honestly, I would punch this in my calculator exactly like this. So 1 minus 3 halves to the power of 10. Yep, I know that's a terrible number, but you've got to leave it there just like that, okay? And we're going to divide it by 1 minus 3 halves. And I get 113.33 about. So the sum of the first 10 terms is about 113.33. And I hope you notice that this is okay, because as this goes on, because 3 times 3 halves, well, that's not an integer. So 3 times 3 divided by 2 is 4.5. If we add that to 3 times 3 halves squared, you get 11.25, and these decimals are going to get nastier and nastier as you go. Okay, so this one, it's going to be the sum of these first 8 terms is equal to the first term, which notice there's nothing in front of this 5. It means there's a secret 1, times 1 minus 5 to the, that's the common ratio, to the power of n, which is 8, over 1 minus 5. Now notice this one, since all the terms are integers, shouldn't come out with a nasty decimal. Let's see if that works. 1 minus 5 to the power of 8. And then we're going to divide that by 1 minus 5, which is negative 4. And hey, look at that. The sum of the first 8 terms is equal to 97,656. I know what you're thinking. Hey, that's not divisible by 5. You're right, because the first term was 1. So the first term of the series is 12, and each term is 2 times the previous term. So write the information above to represent a sequence. That would be, so the first term is 12, and then 12 times 2 is 24. And the 24 times 2 is 48. 48 times 2 is 96. And 96 times 2 is 192. The information above actually represents a series. Write it numerically. That's 12 plus 24 plus 48 plus 96 plus 192. And I'm just going to do that by hand. 12 plus 24, and by hand I mean by calculator. But I am using my hands to punch the buttons in the calculator, so maybe I did do it by hand. Ha ha, ho ho, how do you think of that? 372. The series has 10 terms. Represented algebraically, well, that would be... Oh, they want us to use a different number one? Okay, so j equals 1 up to 10. The first term is 12. The common ratio is 2, and that's going to be to the j minus 1. Find the sum of the series. That would be the first term, 12, times 1 minus the common ratio to the 10th, because that's how many terms we have, over 1 minus 2. Now, 1 minus 2 to the 10th, so 2 to the power of 10 is a huge number. Oh, 1024, that wasn't as bad. Take that away from 1. That's 12 times negative 1023 over negative 1, which is really just 1023 times 12. And you get, well, the sum of those first 10 is equal to 12,276. Very good. Represent those first five sums geographically. Geographically. Yeah, go ahead and pull out your atlas. Let's get to work. Okay, so I'm actually only going to worry about positive numbers here because none of those are going to be negative. These will be ones. You know what? Since they only want the first 5 terms, I'm actually going to use every 2 boxes as 1. So that's 1, 2, 3, 4, 5, because I can. Boy, this thing is going to get out of hand right quick, lickety-split. And in fact, we know that this has to get up to 372. So I guess this needs to get up to 400. So 3 is going to be 100. 200. Nope, that's not going to cut it. 2 is going to be 100. 100, 200, 300, 400, 500, and there's your 50s. Oops. How did that happen? Those are not your 50s. Oops, how did that happen? Where did my axis go? There we go. Yeah, the singles are your 50s. I just marked off the 25s before I did the 50s. That was weird. 50, 100, 152, 253, 354, 455. And I'm going to put the 25s too. I'm going to leave it at that. And really, we're going to be good enough. So the first term was 12. So 1, 12. That's under 25. It's like right here. The next term is going to be 12 plus 2 times 12, which is 24. 12 plus 24 is 36. So that's a little bit under 50. A little bit higher than, a little bit between 25 and 50. The next term is going to be 36 plus 24 times 2, which is 48. Which is 84. So 3 is going to be 84. Around there somewhere. Then we're going to do 84 plus 2 times 48, which is 96. Add those together and you get 180. Do you see where this is going? 4 goes to 180, 150, 175, 180, around there. And finally, the fifth term is going to be 180 plus 2 times 96, which is 192. Add that to 180, and you're going to get 372. Something like that. And you can kind of get the idea of what it's doing, can't you? Okay. There's your geometric sequences. I hope you learned a whole bunch, or maybe a lot of it was a review. If so, that's great. If you have any questions, send a message to your instructor. Until next time, this is Mr. P signing off. Have a wonderful rest of your day.